Okay, so here I want to talk about the concept of the cross product of two vectors. And so I have two vectors, A and B, drawn here, and these are in 3 dimensions, so I've sort of indicated this perspective here to show you that um, two vectors define a plane, right? If you have two vectors like A and B, you can sort of think about them lying on the same board. And I'm purposely talking about a board. You could say a sheet of paper or something like that, anything that's a plane. Okay, so now what we want to do is look at this sort of statement. Vector A cross vector B. So this is read as A cross B. This thing is a vector, okay? And the way to calculate that vector is you have to sort of use your imagination. The first thing is it's a vector, but it's also a vector that is perpendicular to the plane, the board containing vector A and vector B. Okay, so you've got two options for your vector A cross B, and if you imagine a vector that's perpendicular to this plane, it might look, and you always want to draw it at the same initial point. It's either going to look like this, it's going to point up out of that plane, or it's going to point down through the plane. And so the idea is, in either case, it is perpendicular to the plane that contains both of those vectors. And you can imagine here's a line on the plane, a point to measure that right angle. Okay, so which one is it? Well, what we have is A cross B is one of these. So let's look at this picture again and determine which one it is. So when we say A cross B, we need to imagine twisting vector A towards B. So we're going to think about twisting vector A this way. And then what you want to do is think about through this point, this board, at this point you have this, this screw, right, going in at a 90-degree angle to the plane. So you've got this screw, right? If you can imagine twisting this screw this direction, turning A towards B, you're rotating the screw clockwise. And if you do that, the screw is going to twist into the board. And that's how you determine which of these two vectors is A cross B. So since if you twist A into B, your screw would go into the board this direction, vector A cross B points downward. So this is vector A cross B, and this one is not. Okay? Now you might be wondering, well, how do you set up the screw? Well, you always set it up perpendicular to the plane. What if you have the screw go in from the bottom? So here I'm still perpendicular to the plane, but I'm coming in from the bottom. Now if you can imagine turning the screw from the bottom this way, you're still rotating it clockwise, but since you're coming in from the opposite direction, the screw would unscrew, be coming out of the board, so it'd still be going down. So regardless of the orientation of the screw, if you twist A towards B, you're still going to go down in either case, either screwing in or screwing out. But in either case, you go downward. Okay? So how would you get, what would this vector up here be? In fact, the vector up there is really B cross A, which is what you would get if you twisted B into A, rotating it this way. If you had a screw here and you were rotating it left, it would be screwing out this way. Or from the bottom, rotating that way, you'd be screwing into the board. So it'd still be going through the top. Okay, so that's the idea of the vector A cross B. We still don't know a lot about it. That's just the concept. We don't know how long it is or anything. So there's one more thing. Um, the magnitude of A cross B, the magnitude of this vector, of course, would be the same magnitude as B cross A. They just point in opposite directions. And the way to calculate that would be the magnitude of A times the magnitude of B times the sine of the angle between the two vectors. So what we could do is theta would be this angle here, whatever that may be. Okay, so just to remind you, if you take the dot product of two vectors, that's already a number. You don't need magnitude there. The dot product of two vectors is the magnitudes times the cosine of the angle between the two vectors. So these are very similar formulas. Since A cross B is a vector, you need the magnitudes around it to get this number. A dot B is not a vector, it's a number, so you just get this number here, the magnitudes times the cosine of the angle. Okay, and that's how you can determine the length of a cross product vector. In another video, I'll show you how to actually calculate the cross product by using matrix determinants.